Hello. I'm going to go through this with you. Also pay particular attention to what I do on the calculator, okay? So for the first one, it says use the calculator. So I'm going to go to my graphing calculator, and I'm going to go to y equals, and I'm going to type the equations in. And luckily, they're in y equals form, so that's easy to do. So alpha x to get the fraction, and then 1/2 x. Add 5, and then the other equation is 8 minus x. That's not slope-intercept, but it is y equals, so you can put it in like that. If not, you can always change it to say negative x plus 8. You want to just hit the word graph, and a lot of times you can tell where they cross just by counting the boxes. My first guess would be 2, 6. But then again, you can go to the table and come on. And you don't want to see this table, so I'm going to reset my table so that it starts at 2 and goes up by 1s. All right, so 2, 6 right there. It's a point they share. So when you look at this, you can see like 0 gives you 5 and also 8. That's not a shared point. 2 gives you 6 and 6. That's a shared point. You can also do calculate, which is second trace, and you want choice 5, the intersection. You just move the cursor close to it, doesn't have to be perfect, and then you hit enter 3 times, and it'll give you the answer down here on the bottom. Okay, so you want to make sure that you know how to read the table on the calculator. So second graph gives you the table. A shared point would be where they have the same y. Okay, so use the calculator to find the solution. The solution is 2, 6. You can also do substitution to double check your work. Okay. All right, so solve graphically. So I'm going to go to this graph on the bottom. Again, this is not in slope-intercept form, but it is y equals form, so I could use the calculator. Start at 2, and the slope is -1. Okay. So that's going to look like this. And again, you can use the graphing calculator. I would also encourage you to use a ruler on your test because you want to make sure that your line is straight. Mine is not super straight, but hopefully it'll work. And then y equals 2x, add 5. So that's 5. And the slope is +2, so I'm going up. I'm also going to go down, and I did find the point of intersection, so it looks like I did a good job. Okay, so that's y equals 2x plus 5, and this one is y equals 2 subtraction x, and it looks like they cross at -1, 3. And again, I can put this in my graphing calculator and double check. I could also substitute and make sure that that point does make both equations true. Okay, so that's solved graphically. All right, what is the value of f of 3 when f of x is equal to? So they're saying that x equals 3. So my first job is to figure out, am I going to use this, x is less than 5? Or am I going to use this, x is greater than or equal to 5? So 3 is less than 5, so I'm going to use this. So I take the 3 and I replace the x with it. So I have -2 times 3 plus 4, which equals -2. You can do that in your head. You can do a little scrap work, or you can use your calculator. All right, so this is asking me to find the value of f of x when x is 3. Okay. Kristen and Lauren are selling pies for school fundraisers. Customers can buy apple pies and blueberry pies. Kristen sold 6 apple pies plus 4 blueberry pies, and she spent $87. And I'm using A for apple and B for blueberry. Lauren also sold some pies. She sold 3 apples plus 5 blueberries, and she had $70.50. So those would be my 2 equations. Since these are set up in what I call standard form, I have like x, y, equal sign number, in this case a, b, equal sign number, I'm going to look for additive inverses. I'm going to work with the 6 and the 3. So I'm going to keep the 6a plus 4b equals 87. And I'm going to multiply the lower equation, or the second equation, by -2. And I'm doing that so that I get a -6, additive inverses. The -10 is just a product of that, and then the -141 is just by multiplying by -2. So -2 times 3a, -2 times 5b, and -2 times $70.50. Then you add down, and you get -6b is the same as, and I'm just going to grab my calculator, -141 plus 87, and that equals -54. Divide by -6, and I get b equals 9, which is $9 for a blueberry pie. $9 blueberry. Okay, so now I'm going to take that $9 and I'm going to go back and I'm going to plug it in. So I have 6a plus 4 times 9 equaling 87. So I have 6a plus 36 equaling 87. Subtract 36 from both sides. 6a equals 51. 51 divided by 6, $8.50. Not bad, right? So you want to read the story, you want to write the equations, read the story again, make sure you wrote them right, and then I generally look for additive inverses to add the two equations together. All right, so solve algebraically. I'm going to use the fact that they're both set equal to y, and therefore I'm going to set them equal to each other. So if one thing is equal to y and another thing is equal to y, they have to be equal to each other. So then I subtract, that gives me x subtraction 2 equals -5, add the 2, and that gives me x equals -3. So I have -3, comma, -8 is what I'm getting. Let me see. If I plug in a -3, I get -8. No, if I plug in a -3, I get -11. -11. Let me fix that. So that's why you always check your work, right? Check your work, -11. Okay, now, because I did that graphically, I am actually going to double check it. Algebraically, I'm going to double check it graphically. So y equals 3x subtraction 2, and y equals 2x subtraction 5. Hit the word graph. Probably not going to see them cross, because remember I had that answer of -11, but it does look like they're crossing down here. So I'm going to go to the table, and I'm going to look for -3, comma, -11 right here, shared point. All right. All right, solve algebraically. I'm going to use additive inverses again. So, excuse me one second, this paper's making me crazy. All right, I'm going to multiply the top equation by -2 and the bottom equation by +3. So that gives me -4x minus 6y equals -28. That gives me 9x plus 6y, this is why I did it, equals 48. So that gives me 5x is the same as 20. Divide by 5, x equals 4. 4 is the x, I need a y. So 2 times 4 plus 3y equals 14. 8 plus 3y equals 14. 3y equals 6. Sorry, my pen's not working, but I did say 3y equals 6. 3y equals 6. Where did it go? 3y equals 6. Because I subtracted 8 from both sides, so y equals 2. So 4 comma 2. Okay, and again, substitute to check. All right, solve algebraically. I'm going to multiply the top one by 5. That's going to give me 5x minus 5y is equal to 20. I was going for additive inverses. That's why I did it. So that gives me 7x equals 56. Divide by 7. X equals 8. For every x, there's only one y. So this would be a 4 because 8 minus 4 is 4. And again, you can double check it by substituting it. Like 2 times 8 is 16, 5 times 4 is 20, 16 plus 20 is 36. This works. All right, so, and you can also graph it. Solve graphically, solve algebraically, solve graphically. All right, I'm just going to reduce the view a little bit on this if I can remember how I did that. Having a little trouble remembering how I did the view. View. No. Oh, maybe this. No, that's search. All right, maybe I can't. I'm going to try. Move this up here a little bit. All right. Well, this one's good to go, so I'm going to do this one first, okay? So it's plus 2, and then the slope is 3. All right? Plus 2, and the slope is 3. Okay. So this is going to be a solid line. Oh, sorry. So I don't want to touch that. A solid line because it has an equal bar. And then it's shaded above because it says greater than. Okay, sorry this pen's not so great, but this is the idea. I'll show you on the calculator too. All right, now this one I'm going to do in pink if I can get the pen to change. I don't know why this is happening. I don't want to end the recording. Oh, why can't I get the pen to change? Pen, drawing, pink, 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 pink. Pink, red. Okay, that's close enough. All right, so this one. So 3y, add 6x to both sides. Divide by 3. Y is less than 2x plus 4. Okay, so these are really close to each other. 2x plus 4. Okay, I'm going to go here, here, here. Not the neatest, so I am going to definitely show you on the calculator. This is going to be a dotted line. Dotted. And then I'm going to color down, which is all over here. You do want to name this as the solution set. You do want to label. But let me show you on the calculator because it'll be a lot neater. Okay? So on the calculator, you do have to have the inequalities app on. And if you go all the way here and you don't get that big rectangle, you know it's not on. Or if you look up here, it would say quit app. So I'm going to go to apps, choice 7, inequalities. All right, I'm going to put it on down here. So if I go over this way and I hit enter, it allows me to change that. So I'm going to do the less than, enter, and I'm going to put the 2x add 4 there. 2x add 4. So this was the second one that I graphed in, got to get rid of those lines up there, in the like reddish color, okay? So this was the second one I graphed. It was a dotted line and I shaded down, okay? Now the first one I graphed was is greater than or equal to 3x plus 2. So again, I'm going to go down here. If you get this big rectangle, you know the app is on. And this time I'm looking for greater than or equal to. And I believe it was 3x plus 2. And then you hit graph. So see this area here, this like, I guess orange-green section, that's the solution set. So any point in there would work. Any point not in there wouldn't work. You can't see it like way up here, but there is a white blank space. Okay? So that would show you it a little bit neater. Okay, determine if this point lies in the solution set. So I'm basically looking to see whether it makes it true or not. Okay, so I'm going to plug it in. So -4 is less than 2 times 3 minus 10. -4 is less than -4. That's a no. So I don't even have to check the second one, because if it's not true in one, even if it is true in the second one, it wouldn't make a difference. It has to be true in both. Okay, so no, this does not work. Just keep in mind that you're plugging in for x, you're plugging in for y, and you're seeing whether it's true or not true. Plugging in for x, plugging in for y, seeing whether it's true or not true. Okay. A school is having a fundraiser. They can have at most 30 people. They're charging for adults and children. So I'm going to use A for adults. I'm going to use C for children. Okay, so adults plus children has to be less than or equal to 300, because it's saying at most 300. Okay? Now, if they charge $20 per adult plus $10 per child, will they raise at least $4,500? Okay, so now they're saying, well, there's 200 kids, so will this make enough money? So I'm going to plug that 200 kids in. So that means adults plus 200 has to be less than or equal to 300. So adults has to be less than or equal to 100. Okay, so at most I can have 100 adults. Now if I have $20 per adult and $10 per those 200 kids, that's $4,500 I'm trying to make. So a lot of times, like, you have a room that will only hold so many people, and you don't want to supercharge people because, like, people aren't going to come, but you have to make enough money. All right, so this will give me $2,000. And that means 20 adults plus $2,000 has to be greater than or equal to 4,500. So that means 20 adults, if I subtract the 2,000 from both sides, would have to be above 2,500. So now if I divide by 20, that means that adults has to be greater than or equal to, and let me just turn the light back on here because I'm sitting in the dark. 2,500 divided by 20 is 125. So I have this contradiction here because it's saying that the adults has to be greater than or equal to 125, but then on the other side it's saying the adults has to be less than 100. Both of those can't be true at the same time. So this is not possible. Remember, you're looking for something that would make both things true. It wouldn't make both things true, so it's not possible. All right, I would practice with your calculator. I would go through the review sheet, the packet, read the cover sheet, and also, you know, you have that take-home part. Do the take-home part. Double-check the take-home part. Phone a friend. Don't copy, learn, okay? Learning is important. Good luck. Wish you well. Good luck on your test.